Chapter 4, Section 2, Simulating an SoC Project. In this section of the video series, we will be reviewing Propel Builder's verification projects and how they can be used to simplify the process for setting up simulations for your SoC projects. So with that, let's dive into the first part of this video to discuss the purpose for Propel's verification projects. So, the first thing that you should know about Propel's verification projects is that their main purpose is to integrate verification IP in order to create a simulation environment, as well as to generate a set of files to simulate a project. It's also important to note that the intention for verification projects is to serve as a starting point for a simulation environment for an SoC project. Depending on the complexity of your project, you may need to edit some of the files within your simulation environment, like the test bench or do script, in order to simulate your project in a more meaningful way. With that said, there are two main requirements that you should know about when using Propel's verification projects. And the first of which is that all of your relevant IP must be configured correctly ahead of time before simulating your project. Typically, this involves you initializing your project's memory with the memory initialization file ahead of time if your project contains a processor, as well as also setting your processor to simulation mode and disabling debug mode, if you have not already done so. Aside from that, you must also have an existing SoC project created ahead of time before you can create your own verification project. Luckily, each Propel Builder SoC project has a corresponding verification project that is generated along with it during project creation, meaning that we do not need to create our own separate verification projects and can instead use the verification to design icon in Propel's toolbar in order to easily alternate between the two projects. With that said, let's move on to the next section, so we can check out the main files that are generated with each verification project in a little more depth. The first thing that you should know about verification projects' generated files is that each time you press the generate icon in Propel Builder, all the simulation files in the sim directory of your verification project will be regenerated. If you have already generated a simulation environment before, then these files will be regenerated again with the latest settings from your project. Consequently, it's important that you create separate copies of the following few simulation files we'll discuss if you make modifications to any of them, in order to prevent your changes from being overwritten the next time you regenerate your environment. As mentioned before, the most important files for your simulation environments are located within the sim directory of your verification project. The first file that you should know about is flist.f, which is a file list that contains the path to all the RTL files in your project. It's important that the path to your RTL files are correct in this file, as the flist.f file is used to locate these files that are used to compile and simulate your project. The second, and most important file that you should know about, is msim.do, which is a simulation script that essentially automates the entire model sim simulation flow and compiles your files, then invokes the vsim simulator and advances your simulation ahead in time. Something I want to point out before we proceed is that the asterisk next to each one of these files' names is used to indicate that that file is a good candidate to be modified. For example, the msim.do script is often modified in order to change the way that your project is simulated, or to do additional things like add different waveforms or simulate your project for a different amount of time. With that said, the third file that you should know about is wave.do, which is another do script that adds all the signals from your DUT to your waveform display in ModelSim. This file is primarily used for organization, and can be modified to change the various signals or waveform configuration for the waveform display in your simulation environment. The fourth file that you should know about is the generated system Barolog test bench file, which is used to interface all of your verification IP with your DUT and provide stimulus. By default, this test bench only provides stimulus to initialize your design, and is another good candidate for modification in case you want to try different stimulus for your SoC project. Finally, the last thing I want to point out from the sim directory of verification projects is the hdl_header folder, which contains two files that can be used to enhance your usage of the generated simulation environment. The first of these files is soc_regs.v, which contains all of the register address definitions for your SoC project. And the second file is sys_platform.v, which contains the various parameter declarations corresponding to different parameters for the components in your SoC project. Now that we've reviewed the main files that are generated with each verification project, let's transition to my desktop view so we can take a quick look at what the verification project flow might look like. So, as mentioned before, the first requirement for simulating our verification projects is to ensure that all the relevant IP in our SoC project are configured correctly. The first thing we're going to do in this case is check out our RISC-V CPU in order to disable debug mode and then enable simulation mode. After we've done that, we'll move on to our system memory component in order to ensure that it has been correctly initialized with our memory initialization file. Now that we've seen that our system memory is correctly initialized, we'll return back to our schematic view and then use the verification to design icon from the Propel Builder toolbar in order to switch to our verification project. Since we've made some changes to our SoC project, the first thing we're going to do here is reload our DUT by double-clicking the component in order to ensure that our changes from before are synchronized with our verification project. Before we move on, one thing I want to point out is that you can also expand this DUT component to take a look at your SoC project again and to also make connections to different ports and nets within your SoC design with verification IP for better debugging. Now that we've finished configuring our simulation environment, we will now use the generate icon from the Propel toolbar in order to regenerate all the files in our verification project, and then use the launch icon in order to launch ModelSim and automatically invoke our generated msim.do script. That concludes this chapter of the video training series. To watch the next video in the series, select the video titled Section 4.3, Project Scripting with Tickle Commands.